Thank you. So I'm Cath Gripton. I'm from the Observatory for Mathematical Education, which looks at maths education from early years to university level, and we're based at the University of Nottingham. Today we're going to look at stronger practice in maths. So we're all here to give children the very best start in life. And to be able to give children that very best start in life, we need to have maths at the core of what we're doing. Obviously, maths isn't the only thing that children need for the best start in life, but it's one of the key things. So it's the best thing that we can do for our young children is provide them with the social, emotional, physical, language and literacy skills and the maths as well. With all of the things together, that really does give them the very best chance of success in the future. And maths is particularly important because it's one of the strongest predictors of later achievement. So what the math skills that children have in the early years has the greatest predictive power of how they're going to do in school as they progress through the later school years, more so than reading and attention, according to this meta-analysis, which is where you put lots of research studies together and find out what they tell you overall. In this meta-analysis, early maths had the greatest predictive power of what was going to happen later for these children. So maths is central to what children are learning, and not something that it would be nice if we could have some maths in there, not just for the odd occasion, not just for particular children, or not just for children when we think that they are ready. All children are ready for an early maths education, and it's for every day, for every child. When we're talking about the type of maths we mean a broad maths curriculum. The evidence suggests that children need to learn early number sense, and number sense is not just about knowing numbers or recognizing numbers or counting. It also includes the relationships between numbers, how we can use numbers to find things out. There's a lot that comes into number sense. It's more than just recognizing numerals, but that's important too. It also includes early patterning, and pattern's the bit of the maths curriculum that sometimes gets missed, but it's really fundamental, and research evidence shows that children who are good at early patterning tend to be good at maths later on through school. And it also includes spatial reasoning. So spatial reasoning is a broad range of math skills, but they also provide this broad maths curriculum that we're looking to provide all children with from the earliest ages. So if we look at number sense to start with, number sense involves a range of things. So counting is really important, but subitizing is also important too, recognizing straight away how many there are with very small numbers without needing to count individual ones or do anything else mathematically. I think we sometimes forget the importance of composition and comparison as well. Composition is the numbers that make up a number, so that 5 is made of 3 and 2. It's also made of 4 and 1. These are really important things to recognize, the relationships and the numbers that are inside a number that we have. Also comparing numbers, which are the larger numbers, which are the smaller numbers, and where do they come in the number sequence. All of these things provide a good foundation for later maths. And I just want to mention the importance of fingers. Fingers are really helpful manipulative that help children learn early number sense. And sometimes we think that using fingers is a more immature strategy or a strategy for earlier stages of development. But actually adults use fingers quite a lot to work out number things or to hold numbers to hand whilst they're thinking about them. So we can get children to do counting on their fingers, but we can also get them to do all at once subitizing, to know how many they've got. They can also do composition, like this clip of video where the child shows 5 and then they show 5 another way as a 3 and a 2. So the child is understanding how 5 is made up in lots of different ways to really get a good understanding of 5. And similarly, they might compare where they've got their 3 and 2 to say which one is the larger number, and then try it another way and say, well, which one's the larger number? So there's lots of things children can do with fingers, and fingers are a marvellous resource for teaching early number sense. I mentioned patterning. I think patterning is particularly important and one that we sometimes miss. So for example, I have my toy here. If he's going, he's coming, he's coming, he's coming, he's run away. He's coming, he's coming, he's coming, he's run away. He's coming, he's coming, he's coming. And the child starts to look to the side because they're expecting him to run away, or they might even push him because he's got to go over there, because they're starting to predict from the pattern that they've seen. Children really enjoy patterns, and they're really helpful for their mathematical development. As children get older, they can work with spatial patterns, they can work with repeating patterns. So spatial patterns are how they arrange things. Repeating patterns, you see a steady pattern, that a unit that moves over and over again and again. So the young child here who's got a stick and a leaf, they see leaf, stick, leaf, stick, leaf, stick. They know what's going to come next. If one of them's wrong, they can fix it. They understand that repetition that they see in the pattern there. And that understanding of the unit of repeat is something that happens to children when they're about 5 or 6 years, but we're building towards that in the early years. We're also helping them with pattern translation, so where they see a pattern in a different context. So we had the puppet pattern a moment ago. That same pattern could be clap, clap, wiggle, clap, 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 wiggle, clap, 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 wiggle, because it was 3 things and then 1 thing that was different. So you can do the same pattern in lots and lots of different ways, and that helps the child understand the pattern. And I said that spatial reasoning is a broad range of things. Spatial reasoning includes position and direction. It includes being able to put shapes together or apart when we're building, constructing, or doing jigsaws. It involves symmetry, so things being reflected. It involves shape properties, understanding which way round things are, our way to find our way to get to somewhere, that things can be larger and smaller, but the same, but just scaled up or scaled down. There are so many aspects of spatial reasoning that cut across shape, space, and measures, as well as involve elements of number and pattern too. So spatial reasoning also really helps children to develop their later mathematical skills, as well as enjoying and developing their current skills. To support all of this, for practitioners, they need to know about child development in maths. So that would be knowledge of developmental progressions. So these are not small steps, they're not activity plans or the plans that you might have for what you're going to do first and after with the children. It's about the key developmental milestones, the things that build upon each other in maths. So they're kind of typical trajectories of development, the big, broad conceptual leaps that children make so that they can work towards the mathematical understanding that we need them to have. And research shows, particularly when you combine research across different research projects and different studies and bring it all together, that knowing about these key developmental steps is really particularly important in maths. And this is something that was underlined by Ofsted in their Best Start in Life Part 3 report, that because of the nature of maths, whilst everybody needs to know about child development in all the areas of learning, in maths it's particularly crucial because of the way that earlier understanding is built on, later understanding is built on earlier understanding, so that we need to know about those so that we know how they typically progress and we can build upon what they already know. It's important in all subjects. It's particularly important because of the way that maths works. And there are a few examples of these type of developmental progressions that help practitioners remember what comes early and what comes later in maths. So here's an example that some people might recognise. If you did the EYPDP programme a couple of years ago, which a large number of practitioners in England did, you might recognise this developmental progression, where you see the different areas of maths and what it looks like at an earlier and a later developmental stage. At the side there are approximate ages, but it's not the ages that are important, and they are not age-related expectations. It's about what comes first and what comes next, regardless of the age of the child. Here's another example from the Spatial Reasoning Toolkit. I'm a member of the Early Childhood Maths group, and we created the Spatial Reasoning Toolkit to help practitioners to work out what comes earlier and later in different aspects of spatial reasoning. So the same as before, we kind of ignore the ages to the side and we say, well, what comes first, what builds upon that, and what comes next, which helps with assessment. It helps us to think about provision. It helps us with interaction with children to decide what they might now need to learn to move to the next developmental stage. And here's another example. So I work on the Counting Collections programme at the University of Nottingham, which has been evaluated by the Education Endowment Foundation. And in that programme, it's based upon developmental trajectories or developmental progressions of what comes earlier in early number and what comes later, and this example is for counting. So it's helpful in lots of contexts to have these prompts for what comes early and what comes later to help our subject knowledge. And then the next thing is then how are we going to teach this early maths to children from birth to 5? And the best way is through guided play, according to research. from taking lots of research studies and putting them together and finding out overall what seems to be the best way to teach early maths, always are very helpful. There's a range of different approaches you can take, but guided play seems to be the one that leads to the highest attainment for children. And guided play means, in this context, that the child has autonomy, that they have choice over what they're doing, but the practitioner knows where it's going as an overall learning goal, so they know what's going to happen in those developmental progressions we mentioned a moment ago. And then the adult is able to play with the child, to maybe sometimes model things through the play, to provide a few hints and tips, the occasional question, but not too many, whilst playing, being able to adapt to individual needs, interests, knowing what the child needs to learn next. So through guided play, we can really support children to learn mathematics and to have a really strong attitude to mathematics, as well as to do well in it. And then the final thing to mention is where it is in the education system we should be addressing disadvantage in maths. And really the evidence is that there is already a very large gap between children who are eligible for free school meals and children who are not by the time we get to the early learning goals at the end of the reception year. So at 4 to 5, 65% of children eligible for free school meals achieve the number early learning goal, 64% for numerical patterns, compared to 81 or 83% of their peers. So we already see that difference in their attainment paths, or their likelihood of them being able to achieve those early learning goals in maths by 4 to 5 years. So this means that the most important maths teachers in the whole of the education system are the maths teachers in early years. They can make the biggest difference. So the practitioner's job is crucial for early maths, because we can make the difference to make sure that that gap doesn't embed, doesn't start in early years. We give them the best start we can in maths, then they really will then continue to do well through the maths education system, according to how things have gone to this point for children in this country. So to summarise, I think we need to commit to, for a strong practice in maths, we need to commit to maths being essential for a best start in life, that a broad maths curriculum is needed for all children, that practitioner knowledge of progression in maths is really important, and everyone needs to work on that if that's something you don't feel so confident in, and that learning maths through guided play is an optimal way to learn maths, and that we need to address disadvantage in maths through the early years practice. That's the opportunity to make the greatest difference for these children before it starts to embed as it works its way through the school system. So I would recommend a number of ways in which you can develop early maths practice. There are many ways you could do this, and I'm sure you're doing this all the time in settings or settings that you work with. But I would recommend the child development training module that Vicky and Joanne mentioned earlier, because there's a mathematics module in the child development training online for as early as an entry kind of way to learn about early maths practice. There are lots of resources on the Early Childhood Maths Group website that can be supportive for different practitioners who want to focus on different areas of maths. Obviously, your Stronger Practice Hubs can also support you with particular programmes that we've already heard mention of today already. And there's also an article there from the Chartered College for Teaching that Helen Williams, my colleague, and I wrote together about the principles of early maths practice that might be useful if you're thinking about developing early maths practice with your colleagues. Thank you very much for listening.